All right, welcome to Module 7. We're going to start talking about functions. Oh my goodness, it's another F word, functions. All right, lesson 7.1a. We've got a first scenario here with Vanessa. So let's read this. It looks like she's buying some bouncy balls at the arcade at Walmart, where for every quarter she puts into the arcade, she gets 3 bouncy balls. That's a great deal. So for every one quarter, she gets 3 bouncy balls. Awesome. Let's go back to something that we've already talked about. State the independent and dependent variables for the situation. So again, it looks like we're talking about, I guess, quarters. We're talking about money, and then it looks like we're talking about the bouncy balls. The bouncy balls. So if you remember, the dependent variable is the one that is dependent on the independent. So the independent's like the driving force, okay? That's the one that's going to determine the other one. So let's think about this. If we put money in, does that the amount of money that we put in, does that determine the amount of bouncy balls? Or the bouncy balls determines how much money we spend, right? Independent, dependent. So you already figured out the independent is going to be the number of quarters. And about 90% of the time, money will be the independent. And the dependent is going to be the number of bouncy balls. So remember, if we put in 1 quarter, we get 3 bouncy balls. That's awesome. If we put in 2 quarters, then we've got, holy smokes, we got 6 bouncy balls. That's awesome. You can bring one to your math teacher. Super cool. All right, so we're going to complete the table of values, create a graph, label each axis, and then we're going to talk about the graph if it should be discrete or continuous. Ooh, we talked about this. I think this was back in module 2. So we're going to complete the table. Let's do that first. So we found that independent is the X value. The dependent is the Y value. Also a lot of stuff from module 2. Whoa, it's all coming back. So that means the X value here is going to be number of quarters. So I'm going to write that in. And that means the Y value is going to be number of bouncy balls. So for 1 quarter, you get 3 bouncy balls. If you want 6 of them, you already figured out you need 2 quarters. If you put 3 quarters in, you're going to need 9. If you have 30, holy smokes, you have 10. And maybe what we do is we go back and remember, I don't know if you remember in module 2, but we talked about constant proportionality and all this good stuff. And it looks like 1 times 3 is going to be 3, 2 times 3 is going to be 6, 3 times 3 is going to be 9, and 10 times 3 is going to be 30. So we already know that this thing's going to be proportional. It also makes sense. If you have 0 quarters, you'd have 0 bouncy balls. So it's got to go through the origin. But anyway, let's go back to this. They're talking about discrete and continuous. So now we got to remember what those actually mean. And remember that discrete is you do not connect points, okay? And then continuous is exactly what it sounds like. You are going to connect the points. So do connect data or points, I guess we can call it. So what we have to think about is, can I get like a half of a bouncy ball? Can I put in like 1.5 quarters? I can't do that. So when we get this data, we actually, it's going to be discrete. We cannot connect the points because we can't have fractional values of either quarters or bouncy balls. Yeah, not going to happen. So of course, these give us 4 points, gives us the 0.13, the 0.26, the 0.39, and the 0.1030. We're going to graph it. Kind of interesting that we just have the first quadrant too. Interesting. But anyway, let's graph it. So I've got 1 for X, and I'm going to go 1, 2, 3. Oops, I forgot to label it. X, of course, is going to be number of quarters. So I'm going to write that in because they told me right here to label each axis. And then on the side here, we're going to do number of bouncy balls. So I'm going to write that in. And then let's put these points down. We've got 1, 3. We've got 2, 6. So 2 over 6. Definitely looking linear. I've got 3. It's going to go up to 9. And then 10. Yeah, I'm not doing that one. I'm not doing 1030. So that's okay. 0, 0, because again, with 0 quarters, 0 bouncy balls. Oh, well, wait, I'm not connecting it. It's discrete. That's right. I forgot. Discrete means we're not going to connect. Again, you can't have a fractional value. So let's move this up for part C. Why is this situation only graphed in the first quadrant? Why would it only be in the first quadrant? Look at the items that we're measuring. We're measuring money. We're measuring bouncy balls. Can either one of those be a negative value? No. They both are forced to be positive because that's the only thing that makes sense. So why is this situation graphed only in the first quadrant? Because both quantities must be positive for it to even make sense, okay? So you can't have a negative value number of quarters, and you can't have a negative number of bouncy balls. You can have 0, but you can't have a negative. So write an equation that represents this situation. So what's cool is if we actually go back to this table and remember that this is x and this is y, it looks like it's x times 3 equals y each time, or y equals 3x. So 3, of course, just to kind of go through and remember, this is the constant of proportionality because this is a proportional situation. It goes to the origin. It's also our slope. I think we also called it rate of change, so it's got a lot of fun words to it. What we haven't talked about yet is that this is because honestly, this is a very easy situation for you now. I mean, you did some of this stuff last year in math too, but what we haven't talked about yet is that this year, this is also, whoops, I'll move it up. It's also called a function. Yeah, I said it. I said the F word. Oh yeah, I did. Function. So I'm going to read right here. This situation is an example of a function. In this situation, we would say that the number of bouncy balls purchased is a function of the number of quarters spent, or y. This is called a mapping, and it's also a representation of this relation. Holy smokes, what does that mean? And can also represent a function. And mapping is a diagram in which each input value is paired with exactly one output value. Whoa, there's some new words too. Input, output. Okay, so the x is called the independent variable, and it looks like it's also called the input, right? We're putting that value in so that we can get a desired output value back. Ooh, that's cool, output. I like that. Input, output, and of course this is dependent. So I'll just kind of write that on top. Now let's see if this mapping actually represents the graph as well. Let me see if I can move it up just a little bit. 1 goes to 3, which is what we had here, 1, 3. 2 goes to 6, awesome. 3 goes to 9, cool. And 4 goes to 12. Oh yeah, that would work. I didn't have that in the graph, but absolutely, because 4 times 3 is 12. So you might not have seen a mapping before. It's nothing to stress over. It's actually kind of fun, a couple of ovals, a couple of arrows. And again, the mapping to the right, I'm going to read right here, shows the relationship between the number of quarters spent and the number of bouncy balls purchased. So there is a lot of vocab on this page. The math wasn't too challenging, right? You already could figure out that you knew how to graph, you knew independent, dependent, but input, output might be new. And then also this idea of function and mapping. All right, we're moving on to page 2. Here we go. Okay, we're going to look at another scenario. And in the second scenario, we've got Kyle. Whoops, let's make sure that that kind of focuses. Awesome. So Kyle is not hanging out with Vanessa at Walmart. Kyle is actually going to Bright Aid, and he's also going to purchase some bouncy balls at their arcade. The table relates the number of quarters he puts into the machine and how many bouncy balls he will get out. Okay, all right. Oh, I like that they put X and Y. That makes it easy. Now we're going to create a mapping and we're going to graph it. Again, why is it in the first quadrant? Because hello, quarters is money and it has to be positive. And hello, you need a positive amount of bouncy balls. Duh. Okay. So let me stick with the mapping. Pretty easy here. I've got 1, 2. Whoa, I've got 2 twice. Interesting. But I'm only going to write it once. I'm not going to write it twice. And my y values looks like I've got 2, 3, 4, and 6. I'm going to write them all down. And what's happening is if I put in 1 quarter, I will get 2 bouncy balls back. So that's awesome. And then if I put 2 quarters in, I could get 3 bouncy balls. Awesome. But then the crazy thing is if I put 2 quarters in, I might get 4. It's like a surprise for Kyle. He's like, I have no idea what's going to happen, right? But something cool will happen, so we'll figure it out. And then, of course, 3, he's guaranteed to get 6. So that's a little different than what we did before. Wait a minute. I feel like might be on. Nope, I'm on the right page. Okay, just want to make sure I was on the right page here. And okay, so let's see what we got here. So now we got to graph it. No big deal. So here we got number of quarters. And then, of course, we're going to do the number of the bouncy balls. And we're going to label it. We've got 4 fabulous points here. We got 1, 2. We've got 2, 3. 2, 4. 3, 6. And here we go. So 1, 2 is going to be 1 up 2. 2, 3 is going to be 2 up 3. All right, it's looking like a line. Whoa, 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 whoa. Now we got 2, 4. What the flying fig's going on? That looks bizarre. We've got 2 points right here. We've never done that before. That's super weird. Oh, well. And then we've got 3, 6. So 3 is going to go up 6. So the question is this actually a function? Yes, I'm bringing out the F word again, function. Okay. And I'm going to tell you right now, it's actually not a function. So no, and not a function. Again, this idea of function is a brand new term. So let me explain why this one is not a function, yet when we were hanging out with Vanessa, it was. What's happening on here, this is a very broken situation. When Kyle puts in 2 quarters, he doesn't know if he's going to get 3 or 4. Like, it's the unknown. Okay, into the unknown. Yep, Frozen 2. Okay, so we got some craziness going on here. Because it's not a guaranteed, like we know for sure, it's not a function. It's like a broken machine. Okay, so that's actually not going to work for us. So no, not a function. When Kyle puts in 2 quarters, he might get 3 or 4 bouncy balls back. And that's kind of weird. So it's not exact, okay? Because in a function, we want to know that whatever we put in, we have just one connection with it. We have one exact value that will come out. And this is really crazy. We're like, what? That's not even a line. So let's explore this a little bit more. And I think you're going to be able to make the big, amazing connection. Let's talk about Allison. She's going to Walgreens, excuse me. So again, she's not at Brite Aid. She's not at Walmart. Allison's like, forget you guys. I'm going to Walgreens. One, number 3, and she's going to buy bouncy balls there. And the graph here relates the number of quarters she puts into the machine on different occasions and how many bouncy balls she gets out. So this is kind of bizarre. Like with 1 quarter, it's a free for all, right? She might get 8 bouncy balls. Like she can give those to like 7 of her friends. That's amazing, right? Or she might just get 1 and be like, oh man, not my lucky day. So this machine, let's call her, this arcade is definitely broken. Allison will have no idea when she puts in 1 quarter what she's guaranteed to get back. So I almost want to say like this is a broken arcade, but let's explain how this arcade works. Or maybe it's like the most exciting arcade she's ever been to. But it looks like for 1 quarter, Allison might get 1. Or up to 8, maybe just to make it a little easier. So 1 or up to 8 bouncy balls back. I don't know of an arcade machine that does that. That would be really cool though, because I'd love to get 8, right? So for 1 quarter, Allison might get 1 or up to 8 bouncy balls back. So it's not determined. Let's actually create a mapping for this. So what's crazy is my X value, it's just 1 because I don't have any other values for quarters. Okay, and also remember that X is what? It's the independent, and it's the input. So remember it's both those. And then for Y, that's actually called the dependent and also the output. So just kind of remembering that vocab really helps. Holy smokeroonie. So for Y, she can get 1, she can get 2, she can get 3, 4, 5, 6, 7, 8. But I haven't created the mapping yet. So for 1 quarter, she can get 1. For 1 quarter, she might get 2. For 1 quarter, she might be 3. For 1, she might get 4, and give 3 to her siblings. That's really cool. 1 might be 5. Holy smokes. For 1, it might all the way go to 8. Okay, that is a very bizarre mapping, right? So let's go back to this idea of function. I'm going to move this up just a little bit. Is this relationship a function? So if you can remember what I was talking about Kyle when he went to Brite Aid, again, is Allison guaranteed to know right now when she puts in 1 quarter the exact number of bouncy balls she's going to get back? No. Okay. So for that 1 quarter, she has so many different options. So when that is the case, it is a broken arcade. It is now not a function. It is broken. So not a function. I'm going to say, maybe I'll make that exclamation point, just make it really, really, not a function. For every 1 quarter used or put in, there is various amounts. For every 1 quarter used, there is a very, I don't like that. Don't tell Miss Gahagan, I don't think I'm writing that right. For every 1 quarter used, there is a varied amount of options. She can get 1 up to 8 bouncy balls. And again, if it's not exact and I don't have an exact number, then it's really messed up. It's not a function. I do not like the way I wrote that, but I'm gonna let it go. So for every 1 quarter used, there is a varied amount of options, okay? To be a function, you want it to be a one-to-one. And speaking of functions, holy smokeroonies, we're already on the 3rd page. Woohoo! All right. So this 3rd page at the very top actually defines what a function is. Okay. So I'd like to give you maybe just a few minutes at this point, and you might want to, I'd say actually, if you could stop the video right now and to yourself, read this through right here at the top, that would be great. I'm not going to take your time to read it, but if you can just stop the video right now and just take about a minute to read it. Stop the video now. All righty. So you are back. You read the top little blurb where it says function. That actually tells you the different scenarios that we had. And what are some keywords that hopefully came out of that? Let's look at it. They talked about why they're not functions, and it says not a function. Why? Because there is not a unique number. Okay, it's that one-to-one idea. And they talk about if you know the number of quarters inserted in the machine, you can determine how many bouncy balls come up, and then that would be a function. Interesting. So the main idea to be a function, I would say if it is a function, let's maybe summarize here, is that you should have a unique value. I'm going to squeeze it in there. Every input gives you one exact, oh no, output. I'm going to have to write down there. Sorry about that. So function, unique values. Every input gives you one exact output. Okay, let's look at another scenario. Okay, we're not doing bouncy balls anymore. We have enough of those. We're actually going to go to a local amusement park, and the cost for entry is 45 bucks. Okay, awesome. This is not Disneyland prices. This is cheaper. Once inside, you can ride an unlimited number of rides. Woohoo! The mapping represents the situation. Okay, so you can't see the Y there. I'm sorry. But if you decide to go on 0 rides, it's still going to be 45 bucks. That's a bummer. I think you should go on at least a few rides. So maybe we call this number of rides. And it looks like this is cost. Okay, and remember, what is X? What's the name of X? Yep, it's input. It's also the independent. And what is Y? It's the output. And it's also the dependent. Okay, so it's both those values. But anyway, if you go on 4 rides, it's still 45 bucks. 8 rides, 45, 10 rides, super lucky. Definitely not at Disneyland on a busy day because 45 bucks. So we examine the mapping. Now we're supposed to create a graph. So let's go for it. We got to label. Ooh, we got to number the axes. That's kind of fun. Okay, so we know that X here is going to be number of rides. And it looks like the Y value is going to be the cost. Now our cost is going to be 45 bucks. Well, of course, you're going to buy food and all that stuff, but we're just talking about the entrance and being at the museum. So I don't know, maybe here we go, maybe we just even go by 10. So we go 10, 20, 30, 40, and 50. So our magic area there is going to be 45. I might just write that in. And then it looks like number of rides. I think we could just go by 10. So 0 rides, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, that worked out really well. Okay, so we're creating a graph. This is actually going to give us 4 points. It gives us the point 045, gives us the point 445, and the point 845, and then of course 1045. We're going to graph those 4 points. Here we go. So 045 is going to be here. Maybe you're already noticing what type of line this is going to be. 845 and then 1045. Okay. Now, should I connect them? Should I not? Number of rides is can't be a fractional value. Also, money in this case can, but not the rides. So I'll just leave it as that. I won't connect them. But write an equation that represents the situation. Actually, maybe what I'll do just for fun, maybe I'll kind of put like a dashy line just so we can kind of see what type of line this is. What is it? Horizontal. So now we got to remember that horizontal lines have what type of slope? Yep, 0 slope. And the line and the equation for that, again, especially if I made this an XY table up here just for fun, do you notice that every Y value is 45, 45, and 45? So our equation in this case is Y is equal to 45. The question is this idea of function. And as we look at this, yes, I said the F word again, function. Is it a function? So as we look at this, we notice that if you have if you go on 0 rides, it still costs you $45. If you go on 4 rides, it still costs you $45, which is kind of cool. If you go on 8 rides, that's still $45. In 10 rides, $45. So let me ask you, the amount of rides, do I know exactly how much it's going to cost me? Is every input value related to one exact output value? Yeah, it is. So that's the reason why, yes, this actually is a function. Let me move it up again. Yes, function with maybe a smiley face. Okay. So every x value is paired with one exact y value. Now here's the difference. Yeah, I get it. Like, yeah, but it's like every x value goes to 45. But again, asking yourself, if you go on 4 rides, do you know how much you're going to spend? Yeah, it doesn't vary. Let me actually go back to, if it's okay, let me go back to Kyle's situation with the bouncy balls. See, the problem was here, for every x value, it is not linked to one specific y value. So when he put in 2 quarters, he could have gotten 3 or 4. It's like, what's up? Could be 3 or 4. In this case, even though every x value relates to the exact y value, we still know exactly if you ride 4 rides, it's going to be 45. It's not going to vary. Okay, so that's what's going to make it a function. I'm going to move up to 5. I know it's a lot of information. Okay, functions is generally a new concept. Not too much crazy math behind it, but the idea can be a little tricky. Okay, so give yourself a chance. Ashley says that all linear equations are functions. Is she correct? Explain why or why not, and justify your reasoning by sketching a graph. Really, really good question. All linear equations, are they functions? Seems like any line we talked about in the last 10 minutes or so, they were all functions. Interesting. But what if I told you that this is no? Not all linear equations are functions. Okay? There is one scenario, there is one type of line that is not a function. Okay? Let that crock pot for a minute. Do you know which type of line that is? What line is not a function? Okay, I'll tell you right now. It's a vertical line. Vertical lines are not ding, 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 ding. Functions. Okay. Let me give you this example. I'm going to do it in a table of values. What if x was 1 and y is 2, and x is 1 and y is 3, and x is 1 and y is negative 4? Whoops. Okay, sorry, my 4 got a little tweaky. And let's actually plot these points. So I've got 1 up 2, I've got 1 up 3. That wasn't that exciting, but I've got 1 down negative 4. And when I do connect them, I have a vertical line. Now you might be like, but it's a line. It got to be a function. So let me go back and ask you this. When x is 1, what is the guaranteed one specific y value that it will spit out? Well, it can spit out a 2. It can spit out a 3 or a negative 4. See, so this x value of 1 is not related to one specific y value. That's why it's not a function. In fact, let me create a quick mapping. My mapping won't be as nice as yours. You probably have a much nicer mapping if you're sketching it real quick. For 1, you might get 2, 3, or negative 4. So think about the bouncy balls and the quarters. If I put in 1 quarter, think about Kyle. Think about, was it Ashley who went to Walgreens? Whew. But if I put in 1 quarter, I can get 2 bouncy balls, 3, or negative 4 doesn't make sense, but we'll let it go. Not a function. Okay, so we need to remember that vertical lines are not functions. Holy smokeroonies, you're already on the last page. Let's do it. So the last page brings up this idea of the vertical line test, which is really easy and really awesome. You're going to like this. The vertical line test is a visual way to determine if a curve is a graph of a function or not. A relation is a function if there are no vertical lines that intersect the graph at more than one point. Whoa, that was a lot to read. Okay, so let me explain it better with an example. Let's look at 7. So again, we've got 10, 2, 3, -8, 5, 2, -7, 1. So you got to ask yourself, are any of the x values repeated? Nope, they look different. And in fact, if I create a mapping, just to explain it a little bit better, let's see if I can do that. We've got 10, 3, 5, and -7. So I guess I start with -7. I've got 3, 5, and 10. For my y values, I've got 2, -8, 2, and 1. So maybe -8, 1, and 2. And I can just pair it up. Just might be an easier way for me to explain it. So -7 goes to 1. Cool. Oh, wait, I went out of order. Let me do 10 too. So 10 goes to 2, 3 goes to -8, 5 goes to 2, and -7 goes to 1. So again, if I ask you, is every x value paired with one specific y value? So like if I put x as -7, do I know for sure I'm going to get 1? Mm-hmm. If x is 3, do I know? Yeah, I'm going to get -8. Okay, so this is a function. And when you just have points written out, as long as no x value repeats, it is a function. No x value repeats. We're going to write that down. Now 8's cool, but 8 I don't have any ordered pairs. I mean, I guess I do. You know, I've got a couple I can do like 3, 0 and stuff, but I've got a graph. So this idea of vertical line test, if you draw a vertical line anywhere on the graph, what if you go through 2 points? If you go through 2 points, then that means an x value repeats and it's not a function. Well, here I only went through one x value. Sweet. And here I only go through one x value. So awesome, this must be a function. Haha. No, it's not. Because if there's any situations anywhere on that graph that you can draw a vertical line and go through 2 points, then it is not a function. That is the vertical line test. So vertical line test fails. I feel like I'm giving it a big stamp. I feel bad. It passes through 2 points. Okay. And that's actually how easy it is. You might be like, no, it's not that easy. Yeah, it is. Okay. And maybe 8 is easier to understand when we look at 9. Okay. Is there anywhere on 9 that if we draw a vertical line, it would go through more than 2 points? Kind of visualize that. Nah, 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 nah. No, no, no. Woohoo. Does anyone know the name of this graph by chance? Yeah, it's a parabola. Just pushing you a little bit. Wonder if you might know the name of it. Don't worry, in this module, we will be talking about quadratics. Woo woo, quadratics. But yes, we're going to say function with a smiley face. Okay, it does work. So let's look at 10, the amount of hours a person works and how much money they earn. Okay, so hours versus money. If you, with your first job, maybe you get $10 an hour. You know, if you work for 5 hours, you know you're getting $50. Okay, absolutely. For the amount of time you work, it will absolutely, you will know the specific amount of money, especially if you're trying to save for a car, right? If you're trying to save for that awesome video game that you want, right? Or maybe a new iPhone. Okay, so this is definitely a function. I don't have a graph, I don't have ordered pairs, but we've got the brain that common sense says for every hour you work, you should get a specific amount of money. Okay, it shouldn't be like, oh, I work for 2 hours and I get $10, or ooh, I work for 2 hours and get $100. What? Mm-mm. Okay, so let's look at 11. Ooh, it's a V shape. And as we look at this, is there anywhere I can write a vertical line test and go through 2 points, as I kind of sort of sketch? Nope, that's going to be a no. Okay, so absolutely, since the vertical line test does not fail, and it doesn't matter where you do the vertical line test, but you only pass through 1 point, this absolutely is a function. Smiley face. Do you know the type of function that this graph represents? Not sure, because this is a parabola. What if I told you that's what absolute value looks like? Isn't that crazy? So this is an absolute value function. Don't worry, because we're going to have a fun lesson on that too. Last one. You've made it through. You're doing awesome. So as we look at this, and now you're understanding what vertical line test is, although you can draw a line here and it doesn't fail, but if you draw it really in any of those places, it's going to fail. You're going to go through 2x values, okay? So this is going to fail. This is not a function, not going to work. Okay, so again, this is lesson 7.1a, just an introduction to functions.